Hey everybody, Tom Cherryholmes here with another video in the RetroComputing Archaeology series. In this video I talk about the primary difference between Atari DOS I and Atari DOS II. That is, Atari DOS II included what they called burst mode. Burst mode basically allowed for disk input and output to occur much faster than would normally be allowed under the Atari central input and output routines, which normally operated one character at a time, and instead allowed for CIO transactions to be done one sector at a time, much faster. To demonstrate this, we're actually going to boot a copy of DOS I and DOS II here, with a program that basically shows us saving an image and then loading that image back in from the disk. Go ahead and load the save image program. And we'll take a look at it here. This is a simple basic program that draws a graphic on the screen, in this case a basic moire pattern, and then it uses CIO routines to take and save the image in screen memory to a file. Now, this is being done, and this is important to understand, since we're not just putting one character at a time into the CIO channel, but rather specifically specifying that we're going to save exactly 7,680 bytes worth of data at once before we do the SIO transaction. We're ostensibly calling CIO V once. But because of the way CIO works, that is, it works one character at a time, it calls the put routine for the disk device for every single character that goes out to the disk. And that slows things down a lot. We'll see right here. We'll go ahead and draw the image out. It'll take a few moments. And then once it's drawn out, it will take and save the result to the disk. And I chose this particular graphics mode because it's approximately 7.6K worth of data, which gives us about 62 sectors to write. So you'll hear 62 individual little beeps as it writes out the data. And see, you can hear it right there. It's writing out each of those, and as the buffer gets full for a sector, DOS will write the sector out to the disk. Now for the early drives, this wasn't such a problem because the sector layout was still very loose, and so writing at full speed wouldn't have gotten you that much of a performance increase anyway, but I digress. We wind up with a file that is 62 sectors long that we're going to take and load back in using load img. And see, this program is much simpler because we're not having to draw the graphic image, but rather we are opening the file and then altering the IOCB for the file that we just opened again to read back 7,680 bytes directly into screen memory, which is peaks 88 and peaks 89. And we're using the same basic machine language call to do the CIO call like we did when we wrote the image out in the first place. There is a get number 1A here, primarily so I can hit the keyboard when we're done, but that's the only instance of get here. All of the real disk I/O is happening by the single call to CIOV here. Now you'll see that this is DOS 1. There is no burst mode, so it is literally doing 128 individual character calls. So you can see. And there we go. Now with DOS 2.0, what actually happened was they created a set of circumstances where if you open a file in a certain way, that is, you open a file just for reading or just for writing, and you specify that you want more than 1 byte, then DOS, the FMS, the file management system, will automatically go into what it calls burst mode and try to take and grab up to 128 bytes of data at a time and put it directly into the target buffer for a single call from CIOV to the get or the put handler. This makes the resulting disk I/O much faster. We'll go ahead and boot. And we will then load save image again. Same program over here, except this time we're in DOS 2. And notice that nothing has fundamentally changed with the way that we are actually outputting the image, and as you'll see in a moment, how we read it back. Nothing has changed. Only the underlying routines for the D device, which is the file management system, have been changed to make things much faster. We'll see much the same procedure here to draw out the image and to save it. But the difference that you will see here is that writing out the disk image will be much faster. As an aside, what actually happens here is that it will actually take and do the sector read and then adjust the length parameter of the IOCB so that CIOV thinks that it's already done 128 separate reads and writes. Reads or writes. As you can see, that happened much faster. And yes, I was being somewhat simplistic about this. The truth of the matter is it's more like 127 the length is adjusted by 127, leaving 1 byte left for CIOV to bounce back through, so that when CIOV completes that particular transaction, it won't accidentally wrap back around again, because it does the decrement for the length byte before it actually does anything. But that's a small technical detail. And only really of relevance if you're trying to implement burst mode in your own CIO devices. But that's a whole different topic. Of course, the other major thing about DOS 2 is that the disk utility package was separated off into its own program, and thus has to be loaded when you type DOS. But it gives you more memory to work with, among other things. We have our graphic right here, and we'll take and load it back in. And again, the same program as before. Nothing has fundamentally changed. We are still opening the file. We're setting the IOCB to read 7,680 bytes worth of data directly into screen memory, and then calling CIOV to do it. But since we're opening this up for read, and we're asking for more than 1 byte, in fact, we're asking for 7,680 bytes worth of data all at once, the FMS will take care of reading in sectors, blocking everything as needed be, and sending the data, putting the data directly into the buffer, and then calling CIO, telling it that the operation has completely finished, adjusting the length byte by 128 bytes or so as necessary. And you can see the result is much faster. We'll do that one more time. So there you go. This is, in essence, a complete demonstration, a very self-contained demonstration showing what burst mode was, why it was added to DOS II, and the performance increase that you got as a result of using it. I hope this has been informative, and as always, until next time, guys, have fun.